Electricity, a service that allows us to enjoy the many conveniences of today's lifestyle. We have grown so used to a dependable supply of electricity, we seldom think about the complex process and the many resources required to generate and deliver this important product to your home or business. This presentation features one of Seminole's major resources, coal, required to generate electricity. Fuel and related transportation costs typically represent the single largest cost item on your monthly power bill. Fuel is used in huge quantities to fire boilers that produce steam used in the generation process. Various types of fuel can be used, such as oil, natural gas, nuclear, coal, even garbage. When planning a new generating plant, many factors are considered in selecting a fuel source, such as economics, a long-term and dependable supply, and freedom from direct foreign control. Seminole selected coal as the primary fuel for two 600-megawatt generating units located in Putnam County, Florida. Both units began commercial operation in 1984. Seminole entered into a long-term contract with MAPCO Incorporated to supply the majority of Seminole's coal requirements. The balance of our coal needs is purchased on the spot market. Seminole's coal comes from mines located in the Midwest and is transported to the power plant via water and rail. Seminole has a fleet of 111 barges, 14 towboats, and 297 rail cars, all used in the coal transportation process. Seminole entered into an agreement with Central Gulf Incorporated to operate the barges and towboats. To help you better understand this important resource, we're going to take you on a journey from the coal mines to the power lines. This journey begins underneath thousands of acres of scenic farmland in Kentucky and Illinois. Seminole's coal comes from MAPCO's Dotiki and Patiki mines. The Dotiki mine is located near the town of Clay in northwestern Kentucky. The coal seam, the layer of coal that runs through the earth, is approximately 56 inches high at a depth of approximately 600 feet. The Patiki mining operation is located 5 miles southeast of Carmi in southeastern Illinois. The coal seam at this mine averages 62 inches in thickness and is located at a depth of approximately 1,000 feet. This makes Patiki the deepest mine in the Illinois coal basin. At 6 a.m., the first shift of miners arrive and prepare to enter the mines. The miners wear steel-toed boots and hard hats. The hard hats are equipped with lamps, which provide the majority of illumination while in the mines. Miners also carry emergency respirators. Our journey now takes us underground, when the miners board an elevator that takes them to the mine. At Patiki, they are 400 feet above sea level. When they reach the bottom of the shaft, they will be 600 feet below sea level. Once the miners reach the coal seam, they are transported to the mining area through almost 3 miles of underground tunnels by means of diesel-powered rail cars and battery-operated 3-wheeled vehicles. In the mines, there are 7 entries, which are the straight-ahead tunnels. Every 70 to 80 feet, there are crosscuts, tunnels that tie the entries together for ventilation and travel purposes.
Each operating section has its own split of fresh air, and once air has gone by one section, it picks up the dust and the gas, then it goes out and it doesn't mix with the intake air for another section. It's just to keep from dust or gas to build up on your intake air.
The white that you see on the mine walls is rock dust or ground limestone dust, sprayed on the mine walls, ceiling, and floor to reduce the possibility of coal dust ignition. The structures that are visible on either side of the mine tunnels, called cribs, provide additional support to the mine ceiling. The Patiki and Dotiki mines both use a mining technique referred to as the conventional mining process. The mining cycle begins with the drilling of 4 or 5 holes, depending on the width of the coal seam, into the coal face, which is the immediate area of coal to be mined. The holes are 1 7/8 inch in diameter and penetrate 9 feet into the coal. Water continually flushes the hole while drilling, keeping the dust down and for safety purposes. After this drilling procedure is completed, The cutting machine moves into the working place. This machine is equipped with an 11-foot steel cutting device, resembling a giant chainsaw. The coal seam is typically undercut according to the drill hole location, making sure to undercut all the drill holes. The cut penetrates the seam approximately 9 feet. This undercut allows for expansion of the coal upon detonation of the permissible explosive used to loosen the coal. The coal face is now ready for shooting, a term which refers to the actual detonation of the explosives. Shooting is necessary in order to break the coal down into smaller chunks for loading. The shot fireman, the person who handles and plants the charges, follows strict safety procedures during the shooting phase.
First we go in and we'll tamp up, which you'll see in a minute, and we shoot the two inside holes first, and we have a millisecond delay on our caps, and that makes the 2 outside holes go off last, and the 2 inside holes fall down, and then the last holes go off and fall in on top of it from the outside.
Sticks of the explosive are placed into the drill holes, shown here. 2 water dummies, 16-inch water-filled bags, are also packed into each of the drilled holes. These water bags dampen the explosion, reduce the noise level, and minimize the possibility of an ignition. Before detonation, the shot fireman yells a loud, audible warning 3 times. After the shooting, ventilating currents of air sweep the area, and the shot fireman checks to make sure the area is clear of smoke and methane. A loading machine then enters the area and begins loading coal into shuttle cars. Most of the underground mining equipment is powered by large 480-volt electric motors. Power is provided to the vehicles through long, heavy cables. Each shooting yields approximately 50 tons of coal. The final step in the conventional mining process is the pinning operation. Long steel bolts, referred to as pins, are driven into the ceiling above the immediate mining area. This acts to effectively compress the layers of rock and earth above the coal seam, providing greater support. The shuttle cars, on which the coal is loaded, take the coal and dump it onto a ratio feeder, a conveyor system that separates the larger chunks of coal from the load. From the ratio feeder, the coal is carried by conveyor belt and loaded onto a skip hoist, a cylindrically shaped device that brings the coal to the surface, 22 tons at a time. The journey continues when the coal reaches the surface and is dumped onto a conveyor system that takes it to the breaker building, a structure that houses a large rotating metallic drum called a rotary breaker. A screen-like apparatus lines the rotary breaker's interior. Holes in the screen are 2 inches in diameter. As coal enters the drum, any pieces 2 inches or smaller pass through the screen. The larger pieces, which are rocks and reject material, are emptied from the drum into a hopper. From the hopper, this reject material is loaded onto trucks and taken to a landfill. The smaller pieces of coal then go to the coal preparation or washing building. A series of steps takes place in the coal washing process, which removes clay, rock, and pyritic sulfur from the coal's surface, reducing the total sulfur content of the raw coal by approximately 25%. The residue or sludge from the cleaning is taken to a landfill. From the washing building, the clean coal goes to a large, domed storage area, which holds up to 36,000 tons of coal. From the clean coal storage area, the coal travels to the loading facility, where it is loaded into unit train rail cars. There are 75 100-ton capacity cars in each unit. It takes approximately 3 hours to load all the rail cars. When full, the unit train takes the coal to Mount Vernon, Indiana. Our journey now leaves the mines and takes us to the Mount Vernon Coal Transfer Facility, where the coal is loaded into barges. The train enters a structure called the rail dump shed. Inside this shed, an automatic probe trips a switch on each rail car. This opens hinged doors on the bottom of the rail car, and the coal is emptied into underground surge hoppers. There are 8 of these hoppers, each with a 25-ton capacity. From the surge hoppers, the coal is carried by conveyors to the transfer house. From there, the coal is transported to the barge loading area on one continuous conveyor system, which is over a half-mile long. The coal exits from a telescopic chute into the barges at approximately 4,000 tons per hour. The flow of coal is controlled by an operator in a control room overlooking the chute. Because of the rapid rate and force at which the coal flows into the barge, a tugboat pushes against the side of the barge to keep it from drifting out into the river. This is referred to as breasting. The coal must be loaded evenly to avoid damage to the barge. If too much coal is loaded into one end without counterbalancing the other, the barge could buckle or sink. Balanced loading is achieved by shifting the barge back and forth under the loading chute. This shifting is done by a heavy 3,000-foot cable that runs from one end of the barge loading area to the other. As part of the balanced loading, the draft or depth that the barge sits in the water must be uniform on all 4 sides to facilitate convenient operation and fuel economy. Conventional barges are 35 feet wide by 195 feet long, with a capacity of 1,500 tons. Seminole's barges are 52.5 feet wide by 260 feet long, with a capacity of approximately 3,100 tons, the equivalent of 31 rail cars. It takes approximately 1 hour to load one of these barges. When full, the barges are pushed to a fleeting area across from the loading facility and docked offshore. A fleeting area is a location where full barges are placed and configured to make up a tow. The barges are now ready to be pushed, 8 at a time, down the Ohio River. The next leg of the coal's journey begins when the Seminole Princess, a 4,600 horsepower towboat, arrives at the fleeting area and begins the process of wiring the barges together and securing them to the boat. 1-inch steel cables, referred to as face wires, are used to fasten the barges to the towboat. There are 2 types of connections used when wiring barges together. First, the barges are hooked together at each corner with a cable configuration referred to as coupling wires. Secondly, breast wires, commonly referred to as scissor wires, are used to limit movement of the barges laterally.
These scissor wires is tow wires and a backing wire. Each barge is going to have a scissor wire on it. And actually, like that wire there on this string is a tow wire.
Mm-hmm.
Right? And this wire here on this string is a backing wire. And vice versa on the other string. And actually that keeps him, when he's backing up or shoving forward, them wires is what keeps that barge there with this string here together. And backs it up or shoves it forward, whichever way he's going. And it also keeps them breasted in too. And they're 4 parts on each bite. And that's the only 2 wires you got on these tows.
Now that the coupling and scissor wires have been placed, the Seminole Princess is ready for its journey. Princess will push the 8-barge tow 153 miles down the Ohio River, through a series of locks, to Cairo, Illinois. The trip takes 1.5 to 2 days, depending on river current, depth, and traffic. Under optimum conditions, if the current is good, the river is not too low, and boat traffic on the river is minimal, the tow can move at a speed of up to 12 miles per hour. However, it usually averages around 8 miles per hour. Approximately 3 hours after the tow begins its journey downriver, it enters the first lock at Uniontown, Kentucky. Once inside, it takes about 20 minutes to lower the water so the Princess and its 8-barge tow can continue its journey. The next lock, the Smithland Lock, is 72 miles downriver from Uniontown. After that, the barges pass through locks 52 and 53 and continue on to Cairo, Illinois, where the Ohio meets the Mississippi River. Once arriving at Cairo, the Princess docks the 8 loaded barges at an offshore fleeting area, then returns to Mount Vernon with 8 empty barges. Once there are enough loaded barges at Cairo, one of Seminole's 3 larger 7,200 horsepower towboats, like the Warrior, moves in and builds a 12-barge southbound tow. In all, Seminole owns 111 barges and 14 towboats, which are in a constant shuttle up and down the Ohio and Mississippi rivers and through the Gulf Intercoastal Waterway. Once secured, the 12-barge tow begins its journey down the Mississippi River. Pushing a 37,200-ton barge tow down the Mississippi can be very challenging, as Relief Captain Terry Boyles explains.
Well, difficult aspect, I'd say, is being posted on the river, knowing the river stages, where to get, where you can't get, knowing where boats in your vicinity are, both north and south, knowing what your boat would do compared to the tow that you have out in front of it, figuring out the sets and the drafts, and the current, miles per hour, doing 5 or 6 things at one time, which is primarily the hardest part.
The 12-barge tow is pushed 832 miles down the Mississippi to a fleeting area just outside of New Orleans. Once at the fleeting area in Luling, Louisiana, the 12-barge tow is broken down into 2-barge tows for transit through the Gulf Intercoastal Waterway. Seminole owns 10 1,350 horsepower boats that push the 2-barge tows from Luling through the Intercoastal Waterway to Port St. Joe, Florida, a journey of almost 400 miles. 2-barge tows, both empty and full, are in a constant shuttle between Port St. Joe and Luling. The final leg of the coal's journey by water ends when the barges arrive at the unloading facility, Material Transfer Incorporated, in Port St. Joe. The barges are pushed up and secured off dock near MTI. The Captain Sam, MTI's fleet boat, spots or pushes the barges 2 at a time under the huge level luffing cranes used for unloading the coal. The cranes are equipped with 14 cubic yard buckets, which are capable of lifting 10 tons of coal per scoop. It only takes one operator to maneuver each crane. Just as the barges are loaded evenly to prevent damage to the barge, they must be unloaded evenly for the same reason. As in loading, this is accomplished by a cable attached to the barges that shuttles them back and forth. When the barge is nearly empty, a small front-end loader is lowered into the barge. The front-end loader pushes the remaining coal into a pile for the cranes to scoop out. In all, it takes about 2 hours to unload each barge. From the barges, the coal goes by conveyor to a stockpile, or, the majority of the time, directly to the rail car loading hopper. The coal stockpile provides a buffer inventory. Seminole's unit trains, consisting of 94 rail cars each, are filled from the car loading hopper. This hopper holds almost 3 rail cars of coal and is operated remotely from a control room, where an operator monitors the filling of each rail car. During the loading operation, a conveyor system continuously feeds coal into the hopper. The rail cars are weighed empty, then filled and weighed again, to get the gross weight. This procedure ensures that the rail cars are the proper weight, not putting an unnecessary strain on the cars or the rail system. It takes 4 hours to load a unit train. When the train is hooked up to the locomotives, it is approximately 1 mile long. Apalachicola Northern Railroad locomotives then hook up with the Seminole unit train for the first leg of the coal's Florida journey by rail. The Apalachicola Northern Railroad takes the train to Chattahoochee, Florida, approximately 5 hours from Port St. Joe, where it is switched to the CSX Railroad. CSX takes the coal on the final part of its journey to the plant, a trip of nearly 10 hours. When a unit train arrives at the plant site, each car first passes through the coal handling facility, where a rotary dumper empties the coal into a large hopper beneath the building. The car can be rotated and returned to its original position without ever being uncoupled from the train.
We unload the coal train, and we can unload the coal train in 3 hours to 4 hour time limit. We cycle a car through every 90 seconds. We'll receive anywhere from 9,000 to 9,500 tons of coal. Depends on the loading from Port St. Joe. We can either direct the coal directly to the silos from the dumper, we can put it out into storage, or we can put it in what we call active storage and reclaim it with a stacker reclaimer.
The coal is sent to the silos in the plant via conveyor belts. This is where the electricity-making process actually begins. The coal is ground to the consistency of talcum powder, blown into the boiler and burned. The burning coal heats water, which creates high-pressure steam. The steam then enters the turbine generator, where the electricity is actually produced. Electricity leaves the generator at 23,000 volts, stepped up to 230,000 volts, and sent over high-voltage transmission lines to substations and switching stations, where it is transmitted to Seminole's 11-member systems and interchanged with other utilities in the state. This journey actually ends at your home or business, where electricity is received via the members' distribution lines. As you have seen, there are many steps involved in transporting coal to the plant. Each step is equally important: the mining, the barges, the transloading, the rail cars, and each step is dependent upon the other in the transportation process. Thank you for letting us take you on this journey. Perhaps the next time you flip a switch or just enjoy the comfort of your home, you'll have a better understanding of the many resources and complex process required to providing you a reliable source of electricity to your home or business, from mines to lines.